Hi, we are online.
Awesome. So, hi everyone. Welcome back to the Global AI Community on Virtual Tour. Over here in Europe, we are actually into the 9th of April now. We're on a completely different day, but we're still joined by a lot of our US colleagues and on that kind of part of the world. So, up next, we have David Smith. David is actually part of the same team I'm on, so this is great to have a teammate on the call. David is a cloud advocate at Microsoft, specializing in AI and machine learning. And also, if there's any budding R language people on the call, then definitely follow David if you're not already. He's an absolute guru in that space, so he'd be a really, really cool person to keep in touch with. So hi, David. Thank you so much for joining us.
Hi there, Amy. It's great to be here, and thanks for staying up so late to be on this.
Of course. I'm just absolutely buzzed by all of the stuff that we're learning throughout today. Just a quick one, David, whereabouts are you in the world right now?
I am in the San Francisco Bay Area, just a little bit north of San Francisco.
Fantastic. And so what time is it there?
It is 4 p.m.
4 p.m. Okay, great stuff. So yeah, another place to tick off our list from our speakers. We've had people from all over the planet today, so it's really, really cool. But without further ado, I'd like to pass it over to you. I think you're going to talk a bit about pre-built AI.
Yeah, that's right, Amy. I'm going to talk about how you, as developers, talking to our developer audience out there, can put AI capabilities into applications, even if you're not at a stage where you can build your own AI models. So all you need is to be able to access the interwebs, be able to plug some endpoints into applications, and you can give your apps the power of speech, the power of vision. We'll see lots of examples today. It's really easy to do. This is all based on a talk that I prepared for Microsoft Ignite the Tour, which means that there's lots of great resources available to you associated with this talk. If you have a look down on the bottom left-hand side of all of these slides, there's a link which will take you to a GitHub repository, which has all the links to all the resources that I mentioned in the talk, plus all the code that you need to be able to deploy all the demos you're going to see me do here today. So you can give them yourselves right after this talk if you like. Just check out that repository. All right, so let's go ahead and get started. So like I said, this is all about how we can add human-like capabilities to applications. And let's start with what that means, human-like. What are we talking about making apps be able to do? And we're thinking about things like, making apps be able to have conversations, to talk to you via a text interface, think your traditional chatbots, or even speech back and forth. Think about your AI assistants, being able to build things like that into applications. We're also talking about giving apps the power of vision so that they can actually understand the content of images, perhaps automatically generate captions for photos, or even search within a database of photographs, say, find me all the pictures of dogs. This is the kind of stuff that we can do with AI. A kind of a new thing, and I'll actually touch on this later in the talk today, is using the power of AI intuition to automatically customize user interfaces within applications according to what a user's expectations might be. We'll see that later on, as I mentioned. Translation, another classic AI application, being able to translate text or speech from one language into another, and that's a great way of getting your apps a wider audience through those language translations. And there's also some applications around time series data, being able to have a look at spikes in sensor logs or other kinds of perhaps unusual anomalies in security data to identify intrusions. These are all things that we can do with AI. And in general, these are just some examples of what we mean by human-like. Now, what we're going to use to add these human-like capabilities to applications is something called Azure Cognitive Services. You've probably heard about it. You saw one example of Azure Cognitive Services in Seth's talk just before mine, which is all about being able to search through unstructured data. But we categorize all these cognitive services into 5 sort of human-like capabilities: vision, speech, language, decision, and search. And within each of those categories, there are lots of cognitive services available for you to use. Obviously, we don't have time in this talk to go through all of them, but we saw search in Seth's talk just a moment ago. And in this particular application, I'm going to focus on just 3 of these cognitive services. That's computer vision, which is the ability to analyze content in images. Custom vision, where we can adapt that for specific types of images, which we'll use for a retail application. And also personalizer, which is this tool I mentioned that allows us to customize the layout of applications through intuition. Now, as you can see, there's lots of other cognitive services out there that you might want to use as well, but the principles remain the same. The basic process of getting keys and interfacing with endpoints is pretty consistent between all these different cognitive services. So what you learn in the talk today, you can apply to any of the cognitive services you see up here on the screen. So let's start with one specific example, and that's computer vision. And we'll talk about how you can give your applications the gift of sight. And we're going to motivate that with a retail example. Like I mentioned, this is an artificial example, but I have all the code for you to actually deploy this very website, which is a retail shopping website for a company, Tailwind Traders, that sells hardware, things you might find in your garage or in your garden, things like that. And one of the features that exists in this website is an AI-enabled feature. And if you deploy this website and then go to the button right in the middle that says Start Smart Shopping, what that lets you to do is take a photograph. Perhaps you've been to a friend's place, you've seen a picture of a drill that you'd like to buy. So you take a picture of that drill, you upload it to this website, and it tells you whether Tailwind Traders has drills in stock and where in the store to find them, which aisle and bin it exists in. So a nice little tool to be able to search the product catalog via images that understands the content of those images. Let's try it again with a different picture. I've got an image here of a pair of pliers. Perhaps I want to buy those. So I upload those to the website, and unfortunately, it thinks that pair of pliers is a hammer. So this AI-enabled feature isn't working right now within this Tailwind Traders website. But what we're going to do in this session is have a look at how we can both implement and fix that problem so that we can correctly identify the pictures that we upload into that website. But before we do that, it's worthwhile taking a little bit of a diversion to investigate behind the scenes how these computer vision systems work. How does your Photos app on your smartphone understand that this is a picture of a dog? And to drill into that, let's start with an XKCD comic. You might have seen this one. It's where sort of a manager comes to a developer and suggests a new feature for an app. And the manager says, when a user takes a photo, the app should check whether they're in a national park. And then the developer says, sure, that's easy. That's just a GIS lookup. Give me a few hours to implement that. And then the manager says, furthermore, and check whether the photo is of a bird. And then the developer says, well, I'm going to need a research team in 5 years to implement that. Now, coincidentally, that XKCD comic was published almost exactly 5 years ago. And that research has now been done. And now it's not just possible, it's quite easy to implement a feature like that to identify whether a photo is of a bird or of anything else. And the way it works is with something called neural networks. You probably heard about neural networks. There's a great website by somebody I know called Brandon Rohrer. He's got a great website with a repository of all sorts of tutorials and guides about how AI systems work in general. And I've adapted some of his content here with his permission to explain to you how convolutional neural networks work, because they're the workhorse behind all of these computer vision systems. And they're based on something called deep learning, which you've probably heard of. But the thing about deep learning, the word deep there doesn't mean profound. It just means many, many layers, because neural networks, as you can see here, are made up of layers of nodes. This is a very simple neural network. It's designed to take an image as input on the left-hand side, and then on the right-hand side, it categorizes that image as one of 4 things, either dog, bicycle, apple, or tennis ball. So this particular convolutional neural network is designed to detect 4 images, or four types of images, that it can't recognize anything else. And the way it works is you start with an image and pass that through to the neural network here on the left-hand side. That image then gets passed to each of the nodes in the first layer. And then a filter gets applied to that image. And it's a filter just like you might experience in Snapchat or Instagram, except rather than putting a pair of rabbit ears on the bicycle, it does something you might just think of as a random transformation of that image. And that gets applied to this node, a different filter gets applied to the second node, and so on and so on. And then we move to the next layer in the deep learning system. All those images outputs are then combined together, and then another filter is applied. And same for all those nodes, and so on as we move down to the right of this neural network. Now, each of those filters also has the side effect of shrinking the image down by a little bit at each stage, so that by the time we get down to the very last layer of the neural network, this thing that started as an image of a bicycle has been shrunk down through filter after filter after filter to just a single pixel. And a pixel, you can think of it as a grayscale pixel, a number between 0 and 1. We can then interpret the value of that pixel as the confidence that the neural network has that that particular image is a representation of this particular object type. So for dog, we get 0.02. It doesn't really think it's a dog. But for bicycle, we get 0.93. It's fairly confident that is a bicycle. And in fact, that is the highest confidence score. And so this particular neural network is classifying that image as a bicycle, which in this case is correct. So the question is, how do we set up a neural network to do that? Now, you remember I mentioned there are filters at each of these nodes. And these filters are essentially an application of random numbers through something called a convolution. That's where the name comes. It's usually a grid of numbers, maybe a 3x3 grid, maybe a 5x5 grid. And those sets of weights are different at each of these nodes. So what we need to do is to choose a set of weights in such a way that when we put an image on the left-hand side, the pixel that comes out on the right-hand side is the largest number for the correct image classification. And we do that through a training process. We give it lots and lots of images that we know are either dogs or bicycles or apples or tennis balls. And then we choose those weights in such a way that the fewest mistakes are made on the right-hand side after we go through all those filter applications. And how do we do that? Well, that's where the heavy math comes in. So you might have heard things like backpropagation or learning rate or cost functions, all those kinds of things. But you really only need to know any of that if you want to implement a vision learning system from scratch by yourself. But these days, you don't need to do that. There are lots of tools out there that will let you build them yourself, thinking of things like TensorFlow or PyTorch. Or in fact, you can just use a neural network that somebody has already trained for you. So you already know what all the weights are, and then apply that to your own images. And that's what pre-built AI is. So we can take a pre-trained convolutional neural network that somebody has produced for us, perhaps a big company that has access to millions upon billions of images and lots of computing power and lots of good researchers to create a very powerful convolutional network. And then you can pass it in your images, and it will apply all those weights that have been predetermined, generate a classification score on the right-hand side, and hopefully generate the right classification for that image. In this case, it's correctly classifying this as a bicycle. Now, again, this is just a toy example. It only classifies 4 different kinds of images, and it only has 5 layers. In practice, it will a modern pre-trained vision system will probably classify several thousand different types of images, and it'll be based on many millions of images that in the training process. But you can just benefit from all that computation that's already been done for you and just apply it directly to the model. So let's actually see that in action using Azure Cognitive Services Computer Vision Service. I'm going to show you how to do it with code just in a minute, but there's a really easy way to try it. And this is just to go to the computer vision website. Just loading that up right now. This gives you all the information about the computer vision service in Cognitive Services. But if you scroll down a little bit, there's a nice little demo tool that you can use that will analyze a bunch of predefined images for you. One of the cool things you can do is just upload one of your images directly. So I'm going to upload an image directly from my hard drive here of a man in a hard hat. So upload that to the Cognitive Services web page, and now it's applying the API to do an analysis of that image for me. And what comes back is some JSON output, which gives me some information about the image. The first section in the JSON is objects. It's trying to recognize individual objects within the image. In this case, a helmet, a headwear, and a person. We're not going to use that sub-image classification stuff in this example here. We're going to focus on these tags, which is the overall classification of that image using the same process I just showed you with the convolutional neural network. And you can see there are lots of tags that it associates with this image and a confidence score. That's just that right-hand pixel that we calculated. And the one with the highest number is man. So it is classifying this image as a man. And then the second one is headdress. Now that's a bit of an odd one. I wouldn't sort of call this a headdress. I call it a helmet or a hard hat. And you can see that some of the lower confidence scores are coming up as tags for helmet and hard hat, but it has come up with headdress, which is a little bit odd. We'll come back to that in a moment. But before we do, I also wanted to show you how we can do this programmatically. So what I'm going to do here is just pop up VS Code. And what I have here is a bash shell script. This is available to you in the repository. I'm using bash because I'm a Unix guy. I'm familiar with that. You can use any scripting language probably. In fact, you can use any programming language that can connect to the web. I'm just going to use bash here as an example. And I'm also using the Azure CLI to interface with resources. And I'm already logged in to Azure, so I'm going to skip that step. But what I'm going to do is just highlight some lines in the script here and then send those lines of script to my terminal to run some commands to generate resources in Azure. What this one is doing here is just generating a resource group, which is going to use to hold some keys, which are then I'm going to use to access the computer vision API within Cognitive Services. So we'll let that go for a moment to generate that resource group, which I've called AIML20 demo. If you have a look at the website, the GitHub repository, I've got a lot of details behind these as well, if you have any questions. But now that I've generated that resource group, I'm then going to create a Cognitive Services account, which in turn is going to create some keys for me to use. I'm using one of the paid tiers here, but you can actually generate this in the free tier. If you prefer, have a look on the website to have a look at that. Now that I've generated that account and keys, I can use this AZ Cognitive Services account keys list to actually have a look at my keys. And these will come back in just a moment here. All right. It generates two keys, a primary key and a backup key. So you can invalidate one and still use the other. I'm just going to grab the primary key here. I'm going to save this in an environment variable because I'm going to use this in a minute. All right. And that was the next command I have in the script up here, just to save that. And the last thing we need is an endpoint. This is an HTTPS endpoint, which is provided to us by Azure Cognitive Services. It does vary depending on the region you're using. This is the one for the West US 2 region. But now that we have those two pieces, the key and the endpoint, we can then use that to analyze an image. We can upload that as a file, or we can just use it as a link on the web. And in fact, because I have this image in GitHub, I can just click on that URL, and this is the image that we're going to analyze. And then, I didn't run that command. Let me just save that image environment variable. There we go. And lastly, we can use curl to pass in that image URL into the endpoint. So I'm calling curl, I'm passing in my key, I'm telling the input is JSON, and then the last parameter here is just a little bit of JSON to specify the image URL, and passing here the image API endpoint to the curl command. And then we can see the output that we get down right here. It's just a little bit of JSON. It's only the tags associated with the overall image because I only asked for those when I specified the options to the endpoint. But here we see the exact same output we just saw in the website, which is the tags associated with that image where man is first, headdress is second, and so on and so forth. And so you can see as a programmer, you can then manipulate that data to do whatever you want. Let's have a look at just one more example just to show you it works for anything. I'm going to use one more image. This is another link to an image we have in the GitHub repo. And in this case, it is an image of a drill. Let's go back to our terminal and then run the curl command. And to analyze that drill, we haven't done this one before, so we'll have a look at what the output comes back. Okay, here are the tags associated with it, and you can see the highest confidence tag is something called camera. Okay, that's a bit strange as well. I think there is drill further down on that list. But this is an example of where using these general purpose vision systems might lead you down the wrong path. We have very specific requirements here. We want to use the Tailwind Traders website to identify specific objects, and those are specifically the types of tools that are available in the catalog. But this particular vision network that's behind the Cognitive Services API, that's been trained to detect many thousand types of objects. So it can get a little bit confused, especially if things are a little bit inconsistent. So what we need to do is retrain this vision network so that it only recognizes the things that Tailwind Traders sells. Luckily, we can do that with a system called transfer learning. So let's actually have a look at that. So let me go back to our slides. All right. So the next step is to adapt that computer vision model with our own data, in this case, our own images of the products in the Tailwind Traders catalog, using transfer learning. I'm going to do that with something called Azure Cognitive Services Custom Vision, which we'll see in just a minute. But before that, let me explain to you how transfer learning works as well. So this is another convolutional neural network. In fact, it's the same convolutional network I showed you before that detected dogs, apples, tennis balls, and bicycles. But all we've done here has stripped off the last classification layer. And so what we have left are 8 nodes. And you remember that when we put an image in the left-hand side, filters get applied, things get smaller and smaller. So you might imagine that each of these 8 nodes generates, say, a 3x3 image, which you can just think of as a vector of 9 numbers. We're going to call those things features. Now, we don't know what those features represent, but it turns out they're useful in general for classifying images using this trick called transfer learning. Let's see how it works. Let's say I wanted to classify hammers. I could pass it through an image of a hammer, the filters get applied, and now at the end of the network, I just get 8 features, 8 vectors of 9 numbers. And then I associate that with a binary classification, either hammer or hard hat, which is the other type of image I want to classify. So same thing applies there. If I also want to classify hard hats, I'll pass in some images of a hard hat, generate the 8 features, associate with a binary variable. And then I'll repeat that process for lots of images of hammers and lots of images of hard hats. Now, if there are any data scientists or statisticians in the audience, you can probably guess where I'm going with this, because what we have now is just a statistical classification problem. We have a bunch of explanatory variables, those features. We have a bunch of binary indicators. Is it a hammer or a hard hat? And we can fit a very simple model, say a simple logistic regression model, perhaps a 1-layer neural network model. It doesn't really matter, but it's really easy to compute because it's based on data that's generated by the predefined convolutional neural network and the binary classifications that we've provided. And of course, we can extend that to more beyond binary. We can have multiple classifications. And in fact, that's what transfer learning does. So that at the end of the day, we can apply our simple model to the outputs from a brand new image and use that to classify it according to the image types that we provided. And it turns out this works really, really well. It's kind of surprising that it does because our original model might never have seen hard hats or hammers, but nonetheless, it can classify them really well. And that's because these features that are generated by the predetermined model are useful somehow in classifying images in general. So for example, this F1 feature, that might score high for green images, but score low for images that are not green. And then that would turn out to be useful for classifying tennis balls and so forth. Yeah. So if we wanted to do this ourselves, of course, we could do all that from scratch and build our simple model ourselves. But again, there's a service that does this all for you. It's called Custom Vision as part of Microsoft Cognitive Services. So I'm going to show you how that works right now by going to the customvision.ai website, where I've already got things started. So let me go to that website right now. Let me find the right screen. There we go. All right, so I think I have it up here. All right, let me just refresh it and make sure I'm still connected. Looking good. So I've already started this process. So this Custom Vision website is really nice. It just lets you to upload a bunch of images that you want to classify. I've already uploaded pictures of drills, hammers, pliers, and screwdrivers, which are the things that Tailwind Traders sells. As I scroll through here, you can see those images that I've already uploaded. And I've provided all these images for you in the repository, so you can do it yourself. Let me also add a few more images so you can see how this process works. I'm also going to add in some photos of a hard hat. So let me go to our training images folder, go to hard hats, press Control A to select all those and click open. All right, and that's going to upload those to the service, and I need to give it a label. That's that classification that I showed you on the right-hand side. So let's label all of these as hard hat. There we go. And then upload those files. Now it's going to take a few seconds for it to upload over my internet here, but while we do that, just have a look at the numbers of images we've got here. 51 screwdrivers, 50 pliers, just 16 drills. So that's a pretty small number of images, all things considering. But as you'll see, despite that, the model we generate is going to work quite well. All right, so now we have images for our 5 different products that we sell. Now we can go to the train menu up here and train a brand new transfer learning model. There's an option called quick training that we'll use. And now we'll wait here for a while. Well, actually, it's not going to be very long at all. It only takes about 10 seconds, or even less than that, to train that model. So we've actually generated a brand new model from transfer learning to do that. One of the options that you get, by the way, out of this model is the probability threshold. And this is something you determine in the app about how you use the results from this model. For example, you might say, as long as my confidence score is bigger than 16%, I'm going to call it one of those 5 things. And you can see when I do that, I get a recall of 100%. And that means all of the images that exist in my training database are correctly classified by setting that threshold too low. But our precision is also low because we make some mistakes in doing that. On the other hand, if we set our threshold really high, in some cases we won't make a classification at all, but we'll never make a mistake. So you've got to think about what that threshold is going to be. If you're designing an app, say, to detect, cancer in a lung scan, you might want to set that threshold really high. But for a consumer application, a low threshold might be good. You'll make more mistakes, but you won't disappoint the user by not making classifications sometimes. Anyway, now that we have that model created, we're going to export it to use in our app. We can export for iOS, we can export for Android, we can export as a container. In this case, I'm going to export in the Onyx format, which I'll explain in just a moment. And that's going to generate for me a zip file, which I can then use in an application in a way that we're going to explain in just a second. I think I need to click the download button. There we go. So that's a zip file that we're going to use. All right, let me explain Onyx before I use that, though. There we go. So Onyx is the Open Neural Network Exchange format. It's an open standard to send the results of deep learning models and neural network models in general between systems. It's an open source project, which you can find all the details of about GitHub, about the actual standard itself. Now, when you take one of those Onyx formats and implement it in an app, you need a runtime to allow you to pass an image into that model, then generate the classification scores. And for that, we're going to use Onyx Runtime, excuse me, which itself is, again, an open source platform for generating scores from neural networks in all sorts of languages. And we're going to be using the .NET implementation of that. And you can have a look at that on GitHub. If you have a look at the code I provided for the app, you can see a little bit about how the Onyx runtime is used. All we need to do is generate what we call an inference session, and that's generated based on the Onyx file that we exported. And then once we have that inference session, we can give it some input, which in this case is an image. In this case, it's a file that exists on the file system after it's been uploaded into the website. And that generates from the image and the Onyx model a classification. And then all we do is take that classification and search through the product catalog and present that back to the user. So let's see how that works. If you actually have a look inside the zip file, there's 2 files in there. There's a manifest file, a text file, which we don't actually need. And there's a file called model.onyx. On the other hand, if you have a look within the repository, I've actually provided you with that exported model already, but I've called it products.onyx. And that's because within the website application code, it's looking for a file called products.onyx to represent that model. So all I did was rename model.onyx as products.onyx. And then that's the thing I'm going to upload into the website in just a moment. All right. So what we're going to do now is go into the Azure portal where that Tailwind Traders website is running right now. And we're going to go down and have a look at some of the configuration options. And in fact, we're going to go into the development tools. And if you launch advanced tools, that actually launches the Kudu interface, which lets you interact with the website contents directly. So it's going to authenticate me in right now. All right. And if you go up to the debug console, you can do that using Command or PowerShell. I'm actually not going to do any commands at all. Just going to browse through into the file system to the site folder, www-root, and then we have this standalone folder where the Onyx models folder exists. And there you can see that existing products.onyx file, which is not working. So all I'm going to do is to take the products.onyx file that we just exported out of Custom Vision after renaming it, and then drop that file directly into our website. All right. And once we've dropped it into the application, we just need to go back into the app service, go into AIML 20. By the way, there's just a simple deploy button, so you can set this all up yourself and try it yourself. And now I just need to restart my website. All right, that should be it. So with that having been done, let's go back to the Tailwind Traders website. Let's go back to the homepage. Let's go to the upload a photo button, open that up. Let's go back to our images in the repository. All right, and now let's upload once again that picture of pliers that gave us trouble last time. All right, and you can see it has correctly identified that now as a pair of pliers. It has searched through the Tailwind Traders catalog for pliers and returned that directly to the user, which is exactly what we wanted it to do. So that's all working great now. All right, so we've fixed the problem in the Tailwind Traders website with respect to image classification and interfacing with the catalog that way. I think I've got time just for one more example of cognitive services, and that's something called Personalizer. And that's going to let us to adapt the user interface of the Tailwind Traders website dynamically using artificial intelligence. Now, what you might not have noticed when I showed you the Tailwind Traders website before was this recommended department section. So right here, it's showing a hero image, which is Power Tools department. Oh, let me go back one more. But it's also showing Plumbing, Electrical, and Garden Center. The layout of this section of the website was determined dynamically using artificial intelligence, and specifically with a technique called reinforcement learning. Now, the way reinforcement learning works, we'll get into in a minute, but it's actually been used within Microsoft for many, many years now, because it came out of Microsoft Research. For anybody who has an Xbox at home, you might have noticed that when you open up the main panel, the things that you see in the hero pane and all the other options around it tend to change. And that's because they're chosen dynamically based on what you as a player are most likely to want to see and are most likely to engage with. Reinforcement learning is also used in Bing. And in fact, the ads that you see within Bing, the ads that are displayed to you within the web search are again determined by this reinforcement learning. And the same thing in news, in MSN News, the news articles that are shown to you are again based on an artificial intelligence analysis of your behavior and everyone else's behavior. And this reinforcement learning technique is now available to everybody through the Personalizer service in cognitive services. Now, you might be thinking this is just a recommendation system. You know, just put up the most likely thing that somebody is likely to click on and make that the hero pane or the ad or whatever. But recommendation systems have a problem, which you might have noticed if you've ever, say, bought a pair of shoes online. And then every single ad you see for a week after that is for shoes, which is obviously not what you want because you just bought a pair of shoes. So the way that reinforcement learning works is that most of the time it's in what's called exploit mode, which is showing you the likeliest recommendation that you're likely to click on. But some of the times it goes into explore mode, which means it will try some other alternatives, incorporate the data about how that performs, and use that to update the recommendations. And the recommendations aren't just based on what people click on the most. You, as the developer, decide what is meaningful in terms of what people click on. And that means you determine a context. What are the things that you look at to decide whether something is performing well or not? In our Tailwind Traders website, we use the time of day, thinking that people might want to go to different departments at different times of the day of the week. You might think the garden center is more popular on weekends than in weekdays. And we're also going to use the browser operating system, because that might be some sort of proxy of the type of person that is using the website. Another thing to notice is we're using this for anonymous visit to the website. We don't have any login system in Tailwind Traders. So this is just based on people that visit the website. And then we define a reward. In this case, we can find the reward to say how much people spend or how long they engage with a particular feature. In this case, we're going to set our reward as whether or not the hero image was clicked, either a 0 or 1. And then we set the exploration rate for how often it actually tries different options. You can see how we implement that in the website code. Have a look in the repository. You can see it's really, really simple. We just set up our 2 rewards and then sit and wait, and then have a look at the classifications as they come out. So let's have a look at that in action in the Tailwind Traders website. So we're going to go back to the home page. And you can see right now the hero image is for electrical. Now it turns out it would happen to be in explore mode at this point, because if I start refreshing the website, you'll actually see that the most recommended department right now for me at this time of day with this browser operating system happens to be the garden center. And if I keep on refreshing the website, you'll probably see it's going to come up with garden center again, because that's the best recommendation. So I can keep on refreshing this, but eventually it'll go back into explore mode and try one of those other options. Maybe one more time. Let's try it again. Nope, still in showing garden center. There we go. So it's gone into explore mode there and is now trying out the plumbing department as the hero image, and it'll start incorporating the performance of that into the data for future recommendations for me and for everybody else as well. All right, so that's 3 examples of using pre-built AI. We had a look at the Vision API, we had a look at Custom Vision, and we had a look at Personalizer. Like I said, the same principles apply to all the other cognitive services as well. But before I wrap up, I just want to spend a few minutes just to talk about some things you might want to think about if you're going to put these pre-built AI services into your applications. And the first thing you're probably wondering about is how much this cost. First of all, I want to tell you, if you want to try this out, you can get some free Azure credits at the link right there. But in fact, most of the things that I showed you today are actually free to use, because as long as you're just trying it out, just doing a few queries here and there, which you might do as you're developing an application, at that rate, things are pretty much free. It is rate limited, but since you're developing, that's probably not an issue. When you go into production volumes, you're talking lots of people using it at the same time, big images, lots of text, those kinds of things. That's when the costs start to kick in. And you can find the details of how much that costs for your region and for the service you're using by going to that link on the screen right there. The other thing you might be wondering about is what's happening to my data. If you're using these pre-built AI services, say if you upload an image to the Vision API, the image gets uploaded to Azure, it gets analyzed, and then that image is immediately discarded. Azure doesn't store those images or use them for any other service other than providing you with the analysis that you've asked for on your data. All the details about that are available in the compliance section on the Azure website. But something you might want to think about, though, is if you're in a low bandwidth situation, say a mobile app with, say, only sort of mobile data, and it's expensive in time to upload an image to the service, or if you're in a regulated environment, think healthcare, where, say, an image of somebody's lung can't leave the bounds of your firewall according to regulation, there is another option available to you other than sending that image up to Azure, and that's to use containers. The way the containers work is that you download a container image from Azure representing the service. You deploy that directly into your mobile application or within your firewall, and then you use it just like you would use the regular online Azure service, except that the data never leaves your firewall. It only goes directly to the container, and the container gives you those results. The only data that goes out to Azure itself is billing data, how much you've used that, and it's billed at exactly the same rate as the regular Azure services. And you can find information about how to do cognitive services with your containers at the link on your screen right there. The last thing I want you to think about when it comes to putting these AI systems into production is really also the most important one. And that's to think about the ethical side of what you are doing and how it affects your users when you apply these AI systems. Now, that's a really big topic. I could give an entire talk, an entire workshop, in fact, on this topic alone. But just to give you a sort of a little guide, is just think about building applications with AI in a way that enable people as opposed to replacing people. Make sure that you're using your AI applications to make sure they're inclusive to all sorts of users that might be experiencing that. And that's really important, especially when you think about things of using images, perhaps images of people's faces. Is it going to work for the class of users, or the wide variety of users, rather, that are going to use your application? And make sure that any use you make of your users' data is fair and transparent. That's a very short list for a very complicated topic. But if your company does not have an ethical framework for using AI, I strongly encourage you to work with your leadership to develop one. A great place to start is Microsoft's own ethical principles when it comes to AI, which you can find at this link on the right-hand side of your screen there. It's a great place to start, has some good principles for working with AI systems in applications. So to wrap up, we've focused here on pre-built AI. We didn't have to implement things from scratch. We didn't need to have millions of images to solve our models. We're just using the research that's already been done by Microsoft Research and made available to you through these cognitive services. It doesn't do everything, but as we've seen, we can adapt some of them. And we kind of say that these pre-built AI services can solve probably 80% of your AI needs for making your apps have human-like capabilities. In the Ignite tool, we talked about sort of other ways of building applications from scratch. They're linked to from the repository under the titles of AIML 30 and AIML 40, and you can check them out there. The other thing I want you to remember is that AI is not magic. One of the reasons why I went through how convolutional neural networks work, even though you're not building them yourself, it's useful to understand what's going on behind the scenes so you can understand how things can go wrong and what you can do to fix them. All AI is based on data, and understanding how that data is used is critical to understanding about how your app is going to perform, especially in unusual situations, and what its limitations might be. But the main takeaway I want you to have here is, you can try this out. You don't need to be a rocket scientist or a data scientist or anything to use these pre-built AI services. Try them out in your application, see how it works, but do remember about how your app will be used and how it will impact people. All right, lots of other resources available to you at the GitHub repository. Check out Microsoft Docs. Lots of great guides to get you started with all the services that I've shown you in this talk today. And in fact, there are even interactive learn modules where you can try this out yourself in a sandbox. You don't even need to have an Azure account to do this. And you can try out some of the things I've shown you at the link that you can see on the screen right there. And finally, thank you. Give it a go. See how it works, and try and give your apps some human-like capabilities. And I'll hand it back to you, Amy.
Oh, amazing. Thank you, David. So much covered, actually. I think we've seen so many different parts of the cognitive services platform, and also like so many different ways of using it, different ways to consume it, different ways to implement it, stuff like that. So some really, really great sort of like nitbits of information in there. If we can, we've got a few minutes. You absolutely did impeccable on time, and great work, David. So we've pulled together a few questions. I'll start off, and then I think Eve, you've got a couple of questions as well. You mentioned in the custom vision service the small amount of images that you actually needed to train the model, which is obviously great because in the real world, like how easy is it to get your hands on 100,000 images or something like that?
Yeah.
But I guess the question was, are there sort of other best practices we should be considering when we're putting, what are those small amount of images? Is there other things we should be thinking about using the custom vision service?
Yeah, I mean, it's kind of hard to say because it does vary on the application, but I think as a good guideline is that if a human could look at this collection of 10 images and this other collection of 10 images and tell them apart as being different things, then the custom vision service probably would be able to as well. Whereas if there are kind of similar things, like if I had to tell it the difference between pliers and say multi-tools, I'm going to need a lot more different images to be able to make that classification because they look kind of the same and you've got to look pretty carefully to determine the difference. So if the things are looking similar, but you still want to classify them separately, you're going to need more images in that situation as well. Another thing to be aware of is that custom vision is based on, as we talked about, on a transfer learning model, which in turn has been trained on photographs of things, photographs of people, photographs of objects. They're generally images in color. So that means it'll work well if the image that you're trying to train it with is a photograph. It won't work so well if it's not a traditional photograph. I've seen examples where people have talked about, can I use this for microscope images of cells? And the answer is probably not because there is no representations of those or anything similar in the source data. Same thing as if it's a line drawing. Probably not going to work for that. But if it is a photograph and works well for that particular underlying model, it should be okay. And also one of the nice things is custom vision actually gives you a choice of the underlying model. There are ones that are particularly trained well on food. There are ones that are particularly trained well on commercial products. There are a couple of others as well. So choose the underlying model which kind of best matches your particular problem and the type of images that you wanted to reclassify.
Great stuff. No, that's some really, really good pointers for everyone. Yeah, just thinking a little bit more about because I'm sure we probably can all get more than 10 images or 20 or 50 images. So to be able to pick that kind of variety and quality and kind of align in that underlying model, that's really, really good advice. Moving on slightly, then a little bit later, you started to talk about the personalizer service. This service just blows my mind on a daily basis. The fact that reinforcement learning can actually be provided as a service at this point. I mean, it's still obviously, heavy parts of it are still in research. So it's when you were scrolling down and we were changing the top of the Tailwind Traders website, just a quick question. Was the reward there? Because obviously you have to kind of say, yep, like add to that model, like it won, it did the right thing. Is the reward when, say, someone clicks on one of those departments, or is it just that they get to sort of swap between explore and exploit?
Yeah, that's right. I don't think I have the Tailwind Traders website up right now, but it was if somebody had clicked on that hero image, which is the largest image in the sort of the department section, then that was a reward of 1. So basically, every time somebody clicked on that image or did not clicked on one of the other images, it was recording time of day of week, the browser operating system, and then using all that data together to try and predict in the future when somebody comes at a specific time of day of week with a specific browser, what is the thing they're most likely to show or likely to click on? And it would show that 80% of the time, and it would show something else 20% of the time.
I see. Yeah, just wanted to double check on that one because I was like, oh, I know there's the reward piece, but there's also that split, between the 80-20 of explore and exploit. Amazing. And Eve, you had a more of a scenario question.
Yes, because I'm working on something as a side project, and that is somewhat related to this visual search. I mean, that is also something I would maybe consider to use. But first, I wanted to ask your opinion. So, how well is it can it be used for a scenario when, for example, you are looking for books in a book web shop?
So I mean, give me more details about the scenario. Like how would you use
So in this case, you would not want to return just a simple book. We would like to return a book with that specific title.
so I try and identify the title on the book. Yeah.
Yeah. So this the visual with visual search, would it be?
Yeah, that using the custom vision would be difficult because, like, to make that work, you'd have to train it on every possible title you might see, which isn't really practical and probably not the quite application. But there are other Azure Cognitive Services that could apply here. There's one in particular I didn't show one of the outputs from the Vision API, is it will actually detect all the text that it sees within that image, and then return to you the actual text values that you can then look at. So
Yeah, that
that's
was
what
the
you could
B
do.
plan.
You could pass it into the Vision API, extract out the text detection part of that, see if that matches one of the books in your catalog, for example, and then work from there. That you might have more success with that.
Yes, that was actually the B plan. It was more like, would it be possible with the, yeah.
Nice.
Thank you a lot.
We have a couple of questions from the audience, actually, if we take a couple there. So is there a difference between identifying objects in images or videos? Is it different algorithms that are used?
That's a really good question. And the answer is yes and no. Let me start with the no side of it. One of the things that you could do, of course, is you could just take a video stream, extract out a still frame from that video stream, do an analysis of that image just as a regular image, just as we've done. And that works, and that works great for some applications. It also has some problems in the sense that, when you apply that to 24 frames a second, you can get a lot of noise because, the classifications could change just based on variations in the image, all sorts of things, and that's probably not what you want to have to do. So there are other algorithms that'll kind of smooth essentially over the video to generate sort of stable predictions of when a particular object appears in the video stream. That's a bit more complicated, but once again, Azure Cognitive Services has a service to do that. It's called Video Indexer. You can just upload a video to that service, and it will do all that analysis for you. It'll find all of the objects and even the celebrities and people that exist in that video, and then tell you where in the time stream they exist. And you can even upload representations of specific things that you want to find. Say if you work for a company and you want to detect whether your brand is shown in video, you can train it on your own brand and then upload that video and do it that way.
Nice one. No, thank you. Thank you for passing on that information. And then just one more. Somebody asked, they want to know about the algorithms and mechanisms used in the cognitive service. So is it open source? Can anyone adjust it?
It's not open source in the sense that, we don't share the trained models themselves. The only way we provide for you to adjust them is with things like custom vision, which provides the transfer learning for them. The underlying research is available to you. If you have a look at the Microsoft Research Archives and have a look, search for things like transfer learning and so forth, you'll see some of that underlying research, which gives you a guidance to how to apply it yourself. And of course, if you did want to build these kinds of models yourself, you could use frameworks like TensorFlow or PyTorch. Many of those are open source, and Microsoft has opened many of them itself for you to use. But of course, you need data to do that. The data that we use to build our models is, of course, proprietary. But if you have a source of lots of, say, images for a vision application, you can apply those open source models directly to them yourself.
That is perfect. Great one there. Thank you, David. So yeah, I guess we will wrap up. We're a few minutes over there, but David, thank you so much for joining us. That session was really great, and I hope we didn't quiz you too much at the end, but you gave some really, really great answers. So thank you so much.
Thanks. It's been fun. Thanks for having me.
Hey, my name's Akansha Malik, and I'm from Melbourne.